In this video, we're going to look at transformations of some basic parent functions, most specifically dilations. So, first off, we should know our main parent functions, then be able to do translations and reflections. Once we can do that, then we look at dilations, which is a stretch or a shrink. And in this particular video, we're mostly just going to focus on vertical dilations. So, parent functions, well, you've got a few different ones. If we're talking about just a straight line, our parent function is just y equals x. If we're talking about a parabola, we've got y equals x squared, and absolute value of x, that's our v shape, we've got that there. Now, another one that we could look at is absolute value, square root function. Okay, so those are, four of our basic parent functions that we should be able to make some basic transformations with. Again, we're specifically looking at dilations in this video, which is a transformation that stretches or shrinks our function, and you may also see the term compresses in textbooks and other resources. So looking at some vertical dilations here, you notice that each of our four examples have y equals and some number times the absolute value of x. So we're not looking at any other transformations except for these dilations. So because it's a number being multiplied on the outside of where the x is, it has to be a vertical transformation. Okay? If we had to multiply on the inside, so if it's absolute value of 2 times x, and that transformation times 2 is on the inside, then it's a horizontal transformation. But we're just looking at vertical here with dilations. You may not really go too much further than that with dilations. But what we're doing here is, if I were to set up an XY chart, we'll get this. So if I plot these points, we see that our graph is much steeper than our parent function. Okay, so our parent function, just y equals absolute value of x, goes over 1 and up 1 in both directions. So now, by multiplying by 2 on the outside, our graph is much steeper. So since it's a vertical transformation, we think of, does this stretch or shrink our graph? Well, you take the black graph there, our parent function, and if you stretch your graph up from the vertex, you're gonna get it to match that purple graph there. Okay. So multiplying by 2 there is going to be a vertical stretch. Let's take a look at our next example. We're just taking our x values and now we're multiplying by 5, so it's going to be stretched even further, and it's going to be more vertical. It's a very steep graph there. Okay. So multiplying by numbers greater than 1, we see that it's a stretch. So we can look at that as a stretch when a is greater than 1. So now we've got a couple examples down here where a is less than 1. Okay. So now we're multiplying by 1/2. So if we were to do this chart again, by multiplying our x values by 1/2, now our graph is not quite as steep, it's flatter. And again, it's a vertical transformation. So you got to think from our vertex here, vertically, we are kind of pushing that V shape down. We're flattening it out. okay? So then our last example with 1/3, well, I can actually think of this like slope, okay? If we go back to our other examples, think of our first example as a slope of 2 right here, or 2 over 1. Well, I'm going up 1, 2 over 1. With this example here, slope of 5, I'm going up 1, 2, 3, 4, 5, and over what? Come down here when a is less than 1, still the same thing, whether a is greater than 1 or less than 1. Think of a slope of 1/2, so to find that another point from my vertex, I go up 1 and over 2. So with this example here, 1/3, I should be able to take my vertex here and go up 1 over 3 in both directions. And I get my new graph that is more flattened out because my a grade or my a value is less than 1. And so that is a vertical shrink or compression. And there's my graph. Okay. So what I want you to do when you're graphing vertical dilations is once you find your vertex, use this dilation as like a slope to find the next point in both directions on your vertex. Okay? So vertical stretch, we stretch the graph away from the vertex. And basically you're multiplying the y coordinates by a number greater than 1. So looking at these first 2 examples here, you're multiplying the y values from our black parent function here by 2, and you're getting y numbers that get bigger faster. Okay, and then a vertical shrink is where we squeeze or push down the graph towards the vertex, and so we're multiplying the y coordinates by a fraction. Examples we looked at were 1/2 and 1/3. All right, so now let's put all those or that together with our translations and reflections in a few other examples. So as a reminder here, reflection is going to be where we multiply by negative on the inside or outside. Shifting it or translation up or down is where we add or subtract something there on the outside. A translation or shift left or right, we're going to add or subtract on the inside. And now, as we just looked at here, if we multiply by a value on the outside, we are taking the y values and multiplying by that number. Okay. Now this example here kind of applies the same way, but we're just going to look at examples with vertical dilations. Okay. And recall anything on the outside is a vertical transformation. Anything on the inside with the x is a horizontal transformation. Okay? And anything on the inside has to be opposite. Okay, so let's look at some examples here. Both of drawing a graph from an equation and writing an equation from a graph. So first, couple examples of drawing a graph from an equation. Well, first I want to identify what's the shape of my graph, and then what are my transformations. So I see that my parent function is absolute value of x. That tells me it's going to be a V shape. So now my transformations, well, I've got -1 on the inside, horizontal, and it's opposite. So I'm not going to the left, which is the negative direction on my x-axis. I have to go to the right because, again, it is opposite when it's on the inside. So I'm going to the right 1. All right, I'm also multiplying it by 3. So I'm going to have a vertical dilation. Well, that 3 is greater than 1, so it's going to stretch it. So I say vertical stretch of 3. Okay. So first I find my vertex. So I do my shifts, and it's just to the right one. The only other transformation here is a vertical stretch, so I'm not flipping it at all. So I'm still going up in a V shape. So to get that first point in both directions, I think of this like slopes of 3 over 1. So I go up 3 to the right one and up 3 to the left one. I can go up 3 over one more time because I have room there. And I draw my V shape there. Okay. All right, go ahead and pause. Try the other examples there. Okay, so my transformations here, I've got to the left 3. I've got up 1. And I always like to do those shifts first because I need to plot my vertex. Okay, and this is another absolute value parent function, so I'm going to have a V shape. And then I have a negative 2 that I'm multiplying by on the outside. So those are 2 more vertical transformations. The negative tells me it's a reflection. And then the 2 tells me it's going to be a stretch of 2. I could also think of this now with the whole slope idea as a negative 2 over 1. So now I'm going down 2 and right 1, down 2 and left 1. All right, one more. Pause and give that one a try. Okay, so first off, I see that I've got squared here. I've got some quantity with x squared, so I'm going to have a parabola or quadratic function as my parent function. So I'm going to have a U shape. I've got right 2 and up 2 for a vertex. Then I've got that vertical stretch of 4. So I can go up 4 right 1, up 4 left 1 from my vertex. And then I draw a U shape between my points. All right, last thing, we're going to look at some examples of a graph, and then we have to write the equation. So we're just going to look at absolute value functions here. My parent function for all of these, absolute value of x. Okay. And I want to write out my transformations before I figure out what my new equation is going to be. Okay. So the first one we'll do together. I see my vertex is shifted to the right 1. Okay, it's not shifted up or down. It's open up, so that's not reflected. But I do have to go up 2 and over 1. It's like a slope of 2 over 1, or a vertical stretch of 2. So I only have 2 transformations here. So then I take my absolute value of x, and I think, okay, my right 1 transformation, that's horizontal, so it has to go inside with the x, but it has to be opposite if it's inside, so it's not going, since it's going to the positive direction, I have to do opposite and say -1. And then my vertical stretch of 2, vertical means it's on the outside. If it's a stretch, I have to multiply by that number. So y equals 2 times the absolute value of x minus 1. Okay, pause, try those other 2, and we'll take a look. Okay, so for our middle example, our vertex is going to the left 1 and down 5. So I need to have +1 on the inside, -5 on the outside. And then this one I'm going up 1, 2, 3, and I'm going over 2. It's like a slope of 3 over 2. So technically there's a stretch and a shrink here. So we just kind of put that together. And again, this is where I think it's nice to think of finding that first point like a slope, or your dilation like a slope. So I can just write 3 over 2, and that matches with my graph there. Our last example, our vertex is to the left 2 and up 4. So +2 on the inside, +4 on the outside. It's a vertical reflection since it's open down, so I need a negative out front here. And then I have to go down 3 and over 1 to get to my next point.